a little bit of background to how Geminos came about. So I've, over the last 10 years or so, started quite a few different AI-driven startups. I would say mostly industrial applications, so a bit in oil and gas, clean energy, manufacturing, so Airbus, Saudi Aramco, Chevron, Shell, clean energy, food production, a lot of different use cases. And we were pretty much at the forefront of delivering AI-driven solutions for those kind of markets. So that's previous to Geminos, but I learned a couple of things through that. And one is that there's way more demand coming through for AI-driven solutions than the industry can possibly handle. IDC's out there saying we're going to need 500 million new AI-driven applications in the next 5 years to deliver on Industry 4.0. Well, great. There's about, I don't know, 5 million data scientists in the world. And right now it takes 5 or 6 of them about a year to 18 months to build one solution. So do the math. We're simply unable to deliver that many applications. It's not going to work. So we need a pretty big breakthrough in productivity, but we also need a big breakthrough in quality. And fundamentally, that's about the fact that the current status quo, the current technology of AI is pattern matching in the data, and it doesn't understand the difference between correlation and causality. I'll talk about that in a little bit more detail, but those are the key challenges that I was really looking to address when I started Geminos just over 2 years ago. And in researching those problems, I came across some work out of UCLA by this Professor Jerome Pearl, and that's what we've based this on. We're focused very much on digital transformation for industry. So markets like consumer packaged goods, retail, manufacturing, pharmaceuticals, a lot of interest there. Very big market. This is, currently rated as over $300 billion, growing very fast. So big opportunity for us as a startup. I think one of the things that we've learned as we've done the first few use cases is that this idea of causal modeling and causal inference really helps us to bridge a gap between the business people and the technologists, which is really important, I think. I've done modeling for a long time. I started my first company back in the UK, which was a modeling tool company. It was called Select. So I've been involved in that area, and it used to be a case where we kind of create fancy models, understand the business problem, and then file all that as documentation and go write the code. And I think there's an opportunity with causal modeling and knowledge modeling to close that gap and actually embed those models as part of the actual solution. So they become the code, which is a big deal in my view. Causality is also being regarded as the next big thing in AI, which is great for us. Lots of activity on that front. It's been quite academic until relatively recently, but I think we're making it a practical reality, and pretty unusual startup in that respect. It's a very powerful platform that we've created. Owen will do a demo towards the end of this, so to see what we've done. It's a low-code platform. It's based on established open source, including, of course, TypeDB, which is why we're here. So TypeDB is the repository for our platform. We store our models in it. And then we've built it into Node-RED, which is basically a very widely used IoT low-code platform. And you'll see that as part of the demo. Low-cost subscription to get going, very easy. Apparently there's some background noise I'm seeing. That's not at my end. So I don't know where that would be coming from. Anyway, low-cost monthly subscription to use the tool, and then we charge based on consumption if you actually deploy the models as part of an application, part of a solution. Got a great team, people who have worked with me for a long time. Jerry and I have worked together for about 10 years now, I think. I've done a lot of startups. 7 so far that have been successful, a few that I didn't run myself that got acquired for small amounts, etc. Raised a lot of VC money. My first company selected an IPO on NASDAQ. And the second one was bought by Microsoft. So I spent a couple of years at Microsoft as well, which was fascinating, a completely different experience for me. Jerry's got a lot of experience with startups, again, another serial entrepreneur, a lot of success, a lot of IoT experience as well, especially industrial IoT. So that's pretty important from our point of view as we move forwards into this. So who is this guy, Jerome Pearl? So cool guy, in his 80s now. He was really one of the fathers of modern AI in many ways. He really invented Bayesian networks back in the day. And his work on causality in many ways is an extension of that Bayesian network stuff. So it's pretty widely used in its basic form. And he won the Turing Award for his work of this on causal reasoning. And he actually, very importantly, did a whole mathematical underpinning to this causal reasoning. And we've built that into our product. And he's really tackling this problem of the kind of curve fitting of current data science and the fact that it doesn't understand the causal direction of relationships in the data. And this is becoming a big thing. Emphasis on that by the fact that two economists, Angrist and Imbens, won the Nobel Prize for their work on causality, really based on Pearl's work in many ways. So that was just last year, and obviously a big step forward in terms of acceptance for causality. It's also starting to be used by some interesting companies. At the moment, I would say they're using it to help their data scientists do a better job. A slightly different take on that, which I'll explain in a slide or two. But Lyft, Uber, I think Toyota now is on this list. Microsoft Research did a full-on days track in their research summit last year. They're using it within LinkedIn and Xbox, mostly around customer analytics. Netflix about the same. Uber and Lyft are using it to assess different offers in local markets, etc. Getting some really nice results. But there aren't any real tools to use it, which is where we kind of come in. So we're kind of bringing it to life. And to give you a sense of the level of interest globally here, Harvard did a course about a year ago, and 60,000 people attended. And it was a few days, so it was a pretty big commitment. So there's a lot of interest in this idea of causal inference, as you might hear it called. And a lot of academics coming out now and running courses all over the world. We've just signed up a few really key academics. One of them teaches at Copenhagen Business School, Seattle, Vancouver, University of Essex in the UK is very big on this. But part of the problem is a lot of the papers in the books are frankly pretty impenetrable. It dives into maths pretty quickly, and it's quite hard to understand it. So what we've done is taken all that and kind of distilled it into a very business-oriented message and simplified a lot of that. And there's also been a recent book by one of our academic advisors, which is great. It's called The Effect. And he does a great job, I think, of explaining the importance of all this and how to do the models without getting into the maths. There's a lot of examples at the back, so you can, get the Python code and get the data if you want and go through it. But to get a pretty good understanding of where we're coming from, that book is really excellent. It's available free online as well. Once Owen starts to demo, I'll post the link to it. So if any of you are interested, you can take a look at that and see. It's Nick Huntington Klein is the author's name. So let me explain a little bit in a very simple way what this causality challenge is. So here what I've got is a chart coming up of deaths by drowning and ice cream consumption. So what we see in if I just draw those two things in a beginning of a causal model, I've just got ice cream sales and drownings. And if I draw a chart month by month, just based on the data, I can see a very strong correlation. which is kind of interesting, right? So a typical machine learning system would look at this and think, oh, there's a really strong connection there between drowning and ice cream. But the problem is, it doesn't actually know if there's a causal direction between the two. So not only does it not know if there's actually a causal relationship, it doesn't know which direction it might be going in. Now, you know, a savvy data scientist might look at this and without applying any common sense to the problem and think, wait a minute, you know, if I drowned, I'm not going to go buy ice cream. That's pretty logical, right? So clearly it can't go in that direction. But I don't know, my mom always told me if I ate an ice cream, I should wait before swimming. So maybe there's a connection there. But the dumb, you know, poor dumb AI system wouldn't know. All it sees is the strong correlation. And on all the basic metrics that we get out of a typical, you know, AI development platform, it looks like a very strong relationship between the two. Because the reality is that it's about the weather, right? The weather causes both. And unless we actually think about that and model that and understand it and bring in the weather data, we don't know what the causal relationship actually is. And we'll make mistakes. Now, obviously, this is a very simple example that, you know, most people would pick up on. But, you know, the harsh reality is that when we're looking at complex business problems, these causal models are difficult to understand from the point of view of the data. And just looking at the data and looking at the correlations doesn't always tell us what's really going on. And it's one of these kind of fundamental challenges of AI systems development. And we see this over and over again. We've, over the last 15 years or so, worked with some of the top data scientists in the world, and they make these mistakes in the systems they develop because it's difficult to understand what the true causes are and not just pick up on these correlations. As I mentioned earlier, you know, one of the big things we're trying to tackle here is closing this gap between tech and business. The business people talk about what's important to them, customer experiences, branding, revenue, profit, etc. And you know, on the technology side, we talk about digitalization, big data, AI, ML, etc. We create monolithic algorithms that we don't necessarily understand, especially if we're using deep learning. There's just a problem here. And I hear over and over again from the business side, you know, I try to explain my problem, I get back this big algorithm, it spits out answers, no one can really explain to me in words that I understand what it does. It seems to work, all the stats look good, and then it doesn't work after a while. And from the data science side, it's like, well, you know, we're trying to understand the business problem, but we're just and trying to explain what we're doing technically, but we know we're frustrated as well that we're doing too much curve fitting and not really understanding the problem. So that's really what we're looking to bridge with this idea of causality. And we've got a whole process that's we're embedding in the tool in the platform to help support this. So the idea is that you start by modeling the business, and this can be done by subject matter experts. It doesn't require a deep understanding of causality and all the math by any means. So, you know, we're looking at things and relationships and events and causes and effects, timing of it, etc. What interventions can we make? What outcome do we desire? All these things can be described by a business person. And the neat thing is it really does kind of, you know, become the direct path to implementing the technology. So we have a direct path using causality from those business requirements into the data science. And we can use Pearl's causal calculus to analyze and improve the causal models, simulate behavior, interventions, etc. And very importantly, once we actually deploy a system, we can use it to monitor and improve the actual behavior of the newly digitized business, which I think is a really unique aspect of what we're doing. And as we're going through this, we're starting to think about what data do I need to fulfill this causal model? What decisions and actions do I need to augment, automate, etc.? And what can I predict? What can I intervene on? What can I change? And if I do change something, what's likely to happen? So the whole Geminos Causeway platform, as we call it, is designed to help you through this process and bridge this gap between business and technology. So, simple ways. We start with a causal model. I didn't show it here, but we have related knowledge models underneath this. So all the artifacts that are being passed around here are shown in a knowledge model, which will be extremely familiar to those of you that use TypeDB, because it's exactly the same things, entities, relationships, attributes. And I think we've basically just directly taken the schema and structure of TypeDB and implemented that in our platform. So the idea is that these causal models are the kind of dynamics of the system, the events, what they cause to happen, what do we do about it, what are the outcomes, and then the knowledge model shows the kind of static structures, the relationships between things like suppliers and customers and things like that. This is a hierarchy, so we can start at a high level, break it down into multiple levels like this. So if we're looking to replace a supplier for a CPG, we can go through another causal model. And then once we get down to the kind of lowest level, the leaves, the nice thing is we can go into Node-RED, and it's all standard Node-RED anyway, just extended with causal modeling. And we can do implementations. So we can actually, at this point, in a very powerful low-code environment, we can actually do queries against TypeQL or against TypeDB. We can do functions on the data. We can do user interfaces in things like Power BI. Very, very powerful platform. Node-RED as well already has interfaces to just about any data source you can imagine. There are literally thousands of nodes available as standard. All the algorithms available from IBM, TensorFlow, Azure, etc. And as you'll see, it runs on any cloud. It's very powerful, very flexible. So kind of out of the box, we've got this very powerful low-code environment that we've extended with both causal and knowledge modeling. This is how kind of architecturally it works. So as I mentioned, we've got knowledge models and causal models. And approximate to static knowledge and dynamic knowledge. Oops, sorry, clicked. Hit the mouse there. And then we've got the causal calculus that helps us understand all this and analyze it. The models are all stored in our own TypeDB repository, so that's embedded within our platform. You can query that, so if you want to integrate it with other things, the schema structures are very straightforward and published, so you can write queries and do whatever you want with that model information. If you want to use TypeDB as a knowledge layer as well in your applications, we can just output the schemas to that, so that's all integrated. We don't yet have the ability to pick up a TypeDB schema, established one, and bring it back in. But we've got a kind of prototype of that we're starting to build in. So I see a question that there's, is it possible to store multiple possible causal models in parallel? I don't see why not. Yeah, I think it's true that you can use the same causal node on multiple models, right, Owen, if you just nod. So I think you can.
Yeah, yes. I think so. Yeah.
So you can have different versions. Yeah.
It's part of what we want to do, right? Is test different possibilities and like evaluate them, I suppose, for future iterations.
Yeah, absolutely. So the things in our kind of corporate color, this, I don't quite know what you call that corporate color, this blue, are all, specific to Geminos Causeway. The things in red are Node-RED specific, basically, and that all just becomes a Docker image, containerized, etc. And you can deploy that on any cloud and pretty much any scale. So very flexible, very powerful from that point of view. Yeah. So just to give you an example of the kind of use cases we've been working on, there's multiple ones now starting to brew. Still fairly early days, but we've learned an awful lot about how to apply this to industrial problems. Palm oil supply chain is a big problem for the industry. Massive problems in terms of brand damage and that kind of thing. And it's pretty much in everything. I mean, those of you who live in Europe, this is quite a big deal. Less in the headlines in the US, perhaps sadly, all kinds of problems. And the challenge though for the CPGs that use it is that it's 4 to 10 times more efficient than the alternative vegetable oils. And so from the point of view of land usage, etc., almost any other choice is worse. Of course, the problem with that is that it's in tropical areas with, with forestation and peat, and it's also very sadly, a massive problem with forced labor and modern slavery. Now, all the CPGs have lined up and said, hey, in a couple of years, we're going to get rid of all these problems. But traditional AI just hasn't really helped them with this. The data's patchy. They've made some efforts to introduce new data through satellites and radar imaging and that kind of thing. But it's a problem. And they haven't really got to the bottom of it in any kind of scale. So what we've been doing is starting to build causal models and knowledge models for this, and really understand the root problems. So someone's asking what the effect is here. It depends on where you are in the model to a certain extent. So at a high level, it's ultimately brand damage. That's the kind of outcome that we want to change. We want to improve the brand. There's also multiple intermediate steps. So, one level it might be, I want to improve my grievance procedure to the point where ultimately that will impact the brand. And right now, these big CPGs simply don't see all that many of the real problems. So as you'll see, we're breaking this down hierarchically, and at each sub-model of it, there's going to be causes and an ultimate outcome and effect, and intermediate steps along the way. So, it's hard for me to say in one big model like this what the ultimate effect is, but fundamentally what they want to do is let's understand how this is impacting our brand and how we can intervene best to impact that. And then all the steps along the way. What do we have to do? And how can we intervene, and what data do we need? So I think part of the idea here is that instead of saying, here's a sea of data, go look for patterns in it and see what we can find. The idea here is to really get a better fundamental understanding of the problem through causal modeling and knowledge modeling, and then say, okay, what are the gaps? Where do I need data to fulfill this? Of course, then there's a stage of saying, okay, let me look in that sea of data and see if I've missed anything. Don't get me wrong, it's an iterative process. And some people will start with a more data orientation, build the models from that, refine them, etc. So it's iterative and it's hard to know where a given project will start, but that's the fundamental idea, that we're going back and forth between the causal model and the data and really understanding what's missing on both sides, what do we need to fulfill, what decisions do we have to take along the way. And then if we want to actually make a difference here and intervene and run things differently, what are the most important things to focus on? Also, a very important part of this causal modeling is understanding which data isn't important. And we'll see that in a lot of these models, there are what we call backdoor paths, that as long as we make sure they're closed off, we don't have to worry about the data that take us along those paths. And traditional AI isn't very good at that. So causal modeling in that context is really, really important. Next slide just talks about the brand damage, but I think we've covered that enough. So just to kind of reiterate here, this platform is available for use now. We've got a few external people starting to use it. It's very reliable. It's in great shape. We're happy to open it up on a trial basis initially if people are interested. Owen will actually move over to a demo when he starts sharing his screen, so you get to see what it looks like. Very TypeDB centric. It's not designed really as a TypeDB modeling tool. That wasn't our goal, but you can use it that way. You know, as you'll see, we have knowledge modeling. The syntax isn't exactly what you would be used to if you're using the visualization tools in TypeDB, because we're a little bit constrained by what we can do in Node-RED. We're looking to change that over time, but we've got all the capabilities, all the structures there, and we do generate TypeDB schemas. So pretty straightforward from that point of view. Great. Okay. Well, with that, I will stop sharing and hand over to Owen, and we'll kind of tag team on the demo.
Okay. Yeah. Hi, everyone. My name's Owen, and I'm an analyst at Geminos. I'm going to run through a quick demo of our platform. Are you able to see my screen now? You're able to see, right, Stuart? Yeah. Okay. Sorry. Okay. So so I'm going to run through a couple of quick examples of causal models, and also a couple of supporting knowledge models that we've made beneath that, and then also demonstrate some causal libraries that we're embedding into our platform to actually conduct the causal analysis behind the scenes for business users that potentially don't have a deep understanding of the maths behind causal inference. So we're kind of trying to hide that complexity a little bit. So building a little bit more on the palm oil example that we mentioned earlier, and it also pertains to one of the questions we got in the chat, but the final effect of a causal model that we've built, such as this one, would be something like brand damage, or by proxy of brand damage, customer sentiment, right? How are our customers feeling about our products? Is it affecting their buying habits, and so on? And what we want to investigate is the effect of negative events, such as deforestation, peat burning, forced or child labor. What effect are those events having on that final outcome that we want to analyze? Now, the start of what we did here was we did a lot of research into what actually causes these issues, right? And this is probably knowledge that a subject matter expert would have. But obviously, since we're not subject matter experts on palm oil, not quite yet, we had to do a lot of our own research into this area to find out what's actually causing these issues. And some of the things that we've identified, and potentially that consumer packaged goods companies could change, would be certain characteristics of their suppliers, right? Where are they located? What are the characteristics of the locations that are in? Are there loads of trees there? A very simple causal effect would be if they were operating in areas where there aren't any trees already, they wouldn't be able to deforest it. That's a very simple example of one of the types of causal effects we could have here. But what characteristics do their suppliers have? Are they certified? RSPO certification is a rather important data point for suppliers that are being used by consumer packaged goods companies. And then also the quality and recency of their audits is quite a big deal, we think, which is a process that CPGs go through where they try and detect these issues early on and prevent them. So this is kind of a high-level causal model that we've built for this problem. And obviously, as we're testing it, we can make changes to it. And it also shows us what data we need. Because the stage of the project we're at for this particular use case, we don't have all the full data for this project. So what we're doing to test the do-why side of things is we're going to use a different example to kind of I'll step through how we actually analyze a causal model using Microsoft UI library inside of our platform. I'll very quickly show the knowledge model that we were partially provided, but then also improved for palm oil. And I'll zoom out a little bit. Hopefully this should be looking reasonably familiar for people with TypeDB experience, since we've got the entities in yellow, the gray nodes are for relationships, and then we can have attributes connected to entities in white, or we're also storing attributes inside the nodes themselves. And you can also, this is also where you can enter roles for certain relationships, which you can see populated on the connections between the nodes. So that's kind of the causal and knowledge models we would have for a particular use case. And if we were to have data for this project, we would then insert it into the knowledge model and analyze the data in the causal model. So what I'll do now is I'll show a bit of a simpler example and one that we're using to test that process that I just described.
While you're kind of switching there, just on that point of bringing data in. So because the schema is, just standard TypeDB, it's obviously you can use whatever tools you're comfortable with to bring the data in, but also you can just do it within Node-RED. So it's very simple, and we might see that as part of the example in a little bit. But just want to make that clear that it's very straightforward to bring the data into this model, and then we can run the causal math against it as we want to, etc.
Yeah, we can take a quick look at the ETL process for the knowledge model. So I'll quickly show another causal model for a different example, which is based around certain factors in a student's school life having an effect on their grade, right? And ultimately, for this case, we wanted to test the type of high school that a student was attending and how that affected their grade. But obviously, in wanting to test that, we want to try and understand all of the events or variables that might affect someone's grade, which I believe we've taken this data set and from public source. So we've got things like how often they study, whether they listen. That's probably quite it's an interesting one. How many hours they're studying, and even what jobs their parents have, and how that might affect their grade. So once we've got a causal model like this, we can deploy it into our TypeDB repository. And then for the purpose of this one, we haven't created a complex knowledge model. We've created a quite possibly the simplest possible knowledge model, actually, which is just one entity with all of the attributes we need to correspond to the data points that we have, which we've also deployed into our TypeDB server, at which point we can then do some very simple ETL, which we've created using the base Node-RED nodes, such as insertion and pulling files in and so on, which will insert data into our TypeDB database. Once we've done this and we have actual data matching up to our causal model, we can actually analyze the causal model itself. And at this stage, we're directly using the DoY library capabilities. So it's analyzing things like backdoor paths, colliders, and describing how you might be able to close each open backdoor, because obviously that's a key requirement of causal analysis, is not having those open backdoors so that you can isolate true causal effects in your analysis. So we also provide the option to select which variables we want to adjust for, in doing so, closing our backdoor paths. So for this example, there's quite a few backdoors, but we might notice that for each of the open backdoors, each of their paths includes scholarship as a variable. So for example, we can go to high school type, mother's job, scholarship, study hours, into grade would be an example of an open backdoor path for this example. So again, we might notice that all of them actually have scholarship for this example. So an easy way to close all of them would be to adjust for the scholarship variable, which would in turn block all of our backdoors. The final thing we can show, although I believe it's a screenshot of the final result, as it's I believe it won't display on this, but we can look at the final causal analysis of the data and the model of from the DY library, which would provide us with your classic estimand and effect estimate from the DY library, and that's basically where we're at with the platform at the moment. I think we're currently testing the embedding of a DY library such as DY to kind of do the heavy lifting from the causal analysis point of view, and also investigating some other means of causal inference.
Yeah, so there's a question about analyzing the paths about backdoors in TypeDB queries. So the way it works is that because all the basic graph structure of the causal model is stored in TypeDB, we run queries against that, and then we output that to currently the Microsoft DY library. We're also looking at a library that's been published by Uber and also another one by McKinsey. So there's a couple out there. And all of them need a graph input basically. So we query them from TypeDB based on the diagram and the structures there, and then we push that into the API of various backends, and we're going to have probably multiple of those backends built into it, and we'll use those for different levels of analysis. The DY library is the most widely used and the probably the richest at the moment, but each one of them takes a slightly different approach and a different way of looking at it. So nice thing is, from the point of view of a business user, you can look at this and think, okay, now I don't necessarily need all the estimands and all that kind of stuff and that complexity, but at least I can start to think about my causal model. What's important? If I condition on a certain variable, I close the backdoors. Okay, so now I'm starting to understand what data is really important in this model. What are the real drivers? And I don't need a lot of data science knowledge to do that level. So what we're looking at here is a platform that has a few different roles. So one is a subject matter expert with the business knowledge. They can draw these diagrams. They can do the first level of model analysis, just make sure it makes sense. And then, a data scientist could take that over with a bit more training on causal inference and so on. So they can go that next level, look at the data, make sure we have all the data we need, make sure we haven't missed any paths, go back to the subject matter experts in a way that they understand to work that out. And then once we've got a set of causal models to describe the problem, each appropriate effect node, if you like, in this needs to be implemented as a function. So we've got a certain number of causes, we've got an output that we need to create, we've got a function. Sometimes that can be really simple, someone turn the light switch on, the light's got to go on, a really simple function. Sometimes it might be could be a deep learning or reinforcement learning algorithm that runs on this. Could also be an augmented decision that we need to make. So we need to put up a user interface with appropriate data and algorithms behind it to help a human being make an appropriate decision. and also help them to understand the impact of that decision. So, you know, in the CPG example, if they decide to fire a supplier, what is the impact on their supply chain? What's the timing problem with that? How long is it going to take them to replace that supplier with a better source of products? And you know, all those problems, right, that really should be taken into account in that decision, which is part of the overall causal model for this. So yeah, you know, the idea is that you can kind of build it piece by piece and fulfill it using normal kind of algorithms, etc., and technologies, all within Node-RED's very slick low-code environment, and basically implement the whole causal structure as step by step that way. Jerry, you suggested just showing the TypeDB output. Can you do that?
Yeah, sure. Yeah, so one other thing that we can, obviously we can build and deploy a knowledge model onto our own server, but if you'd be so inclined, you can also just export it directly as TypeQL. So yeah, we also provide the actual schema if that's something that someone would be interested in. I also saw somebody ask what the semantics of two connected nodes in the causal model representation, I'm assuming. And that's just a cause effect pair, which would imply that there's a causal relationship between the two variables that we've connected as nodes. And depending on how you connect them, that kind of indicates the direction, which is also indicated by the arrows.
And it's important, one of the things that we've seen a few times is that people start by kind of drawing flowcharts with this. And it's quite important for the kind of underpinning math to work that we don't do that. So the idea is that you don't even really, at this point at least, identify whether it's generally a positive relationship or a negative relationship. You just show the relationship. Now, you know, we're actually looking at that now. We might actually add in, like, you know, red and green lines to show positive and negative relationships. And so as we start looking at the data, that becomes more important as well. But all we're saying here is there is a causal relationship between these two variables, and we need to understand that. And that's what, you know, drives our system, and keep it simple from a business person's point of view. But that's probably one of the key things that we see over and over again when people start using this. They kind of just do flowcharts as opposed to actual causal models. But once you start thinking about cause effect and does this thing impact this thing, then it becomes pretty clear, and it's not a big hurdle. All right, well, I think we've got like 10 minutes or so left. See that Fika has just asked a question now, if I'm saying your name right. Added value. So yeah, when we
before we jump in, so I'm so sorry to interrupt, and hi, I'm back. If Fika, if you want to elaborate on your question on the mic, I can put you on speaker. It may be easier also for you, Stu, to speak directly. So Fika, if you'd like, let us know and we'll put you on the mic. Otherwise, sorry again to interrupt, Stu, I'll let you continue, and we'll let us know, Fika, if you'd like to speak directly.
I think I can at least make a run at answering that question, and then if Fika wants to come on and elaborate a little bit. But I think I get where he's, I don't even know he or she actually. Yeah, okay. So, you know, we come from, Jerry and I particularly, a strong background in knowledge modeling, semantic modeling, etc., and graph structures in general. So when we were looking for a way to initially store our schemas, we obviously looked for something in that category. And what we like about TypeDB, just at a high level, is that all the focus really is on knowledge modeling, right? So it's a very natural fit for us in the way we think about the problems. So I think that's very strong from that point of view. We're also starting to explore, the KGCNN work that Vatical is doing in TypeDB, and we think there's some really interesting opportunities there. I also love the causal inference, the query inference engine that they've put together, which I think is incredibly powerful. And I think we're starting to use some of that already. The way the rules are built in as well is potentially quite powerful for us. So we just really like the platform, quite honestly, and I think it's just a great fit in terms of the way we think about the problem. And as I highlighted in my slides, there are kind of two ways to use TypeDB in this context. One is it's embedded in our platform. It's our repository. You can query that. You could build other tools on it. We're going to make that very open so that other tools vendors can integrate with it, etc. Right? And obviously, the query capabilities of TypeDB are very, very powerful in that respect. So that's great. But then also for the knowledge layer, if you want to have a knowledge layer, separate knowledge layer in your system, which we think is a good way to go, we think TypeDB is a great way to do that.
Great. And Fika, if you want to elaborate at all, I'll just put you on speaker. If there's anything else you want to add, feel free to come off mute.
Yes, thank you. Is it working, my mic? I'm curious.
Yes, I can hear you.
Okay.
Thanks.
Yeah, I like the presentation and the ideas you're proposing. I'm curious because I was also thinking about storing knowledge and learning new kind of relations and things. And if we store multiple models in the same TypeDB workspace, then you really have to think about, okay, which relations are connecting to which world model I'm currently evaluating. And I was also looking at some path analysis. Can I, given my observation, go back to the root node, those kind of things?
Yes.
What kind of tools would you like to see to be kind of added, not to give Vatical a lot of extra work, but just to be thinking about what will be the next possible things that we would like to develop?
Yeah, so our schema basically allows you to traverse the entire graph structure, right? The causal models, etc. So it's very easy to go to root nodes and traverse up and down the hierarchy, etc., just by normal TypeQL queries. So that's very straightforward. And having multiple different causal models that are connected in potentially different ways to the knowledge model is fine. You can do that, so you can have different versions, etc. And in the next version of Node-RED that we're based on, they're going to have much better capabilities for multiple users on a team, etc. So we're kind of waiting a little bit on that. I see Jerry's kind of answering a little bit to our CTO here. I would say at the moment, we're using TypeDB in a pretty simple way. I think the schema has a huge amount of potential. We found it very easy, for example, to integrate between our platform and the TypeDB repository and the DoY library. That wasn't a lot of work to query the graph structure in the way that we need it and output that in a form that DoY can understand. Very simple. As we move forwards, we're looking at things like simulation tools, etc., where we could kind of bring these models to life even more. We're also, as we build out the use of the math in the actual running system. So these causal models become the application because of this, the way we're doing this low code thing. So I tried to get that gardener to shut up. I hope you can't hear the blower in the background, but anyway. we're moving forwards in multiple dimensions. I think, as well as I mentioned earlier, the KGCNN stuff is very interesting to us that you guys are working on, and we're going to explore that as we move forwards. There's also a lot of work in gathering causal structures, candidate ones, and populating those into the repositories so you can kind of build from the bottom up. And I think as we start to do that and do a lot of NLP work, etc., groups like IBM Research have done some work in that area already that we can pick up on because it's open source. So the idea there is that, there was a little bit of a chat going on in the panel there about the causal relationships and how you discover them. And some of that is that you've got to be a subject matter expert, right? You've got to go back and look through the research and so on. And what we're looking for at some level is a causal structure, right? In the semantics of that text. Is it indicating that this causes that to happen? And how might that be described in multiple languages, etc.? And also different contexts, of course. So that gets into some interesting areas. And I think once we start to populate the kind of, the underlying model with candidate causal structures, we're going to need to really, push the query capabilities in TypeDB to start to understand those and present them in ways that users can make sense of, and so they can reuse all these kind of causal fragments and understand them better. But there's part of that thread there that I saw was what you're doing here is in some ways kind of trying to create a model of how you think the world is working, right? And as someone said in the chat, it's never perfect. But the idea is that we want it to be a lot better than we would just get if we run classic data science tools here. And what it's doing is pushing you to go that next level. It's going beyond just the observation of data to really understanding what is happening in the business context, in the business world. And of course, it can be applied to anything, right? I mean, we've shown CPG examples, but we're talking to smart manufacturing organizations, some intelligence related stuff, things like that. There's some really interesting use cases out there. Pharmaceuticals, in general, I would say causal reasoning, causal inference has got most traction with econometricians, which is where most of the books have come from, but also, epidemiology and randomized controlled trials, etc. There's a lot of work being done on using these techniques to really help people solve those kind of problems as well. And the product can be used for those, no problem. So it's very general and very adaptable.
Great. And so perhaps Christian, would you like to elaborate on your question live? We're happy to put you on speaker. I know Owen and Jerry already answered some of your questions, but if you like, I'll just, you should be able to talk now, Christian.
Yeah, I think so. Thanks, Stu, Owen, for this presentation. That's really interesting. And yeah, to come back to the point in the chat, you alluded to the point that the causal models can be adapted as you iterate through the analysis. And I wonder, do you apply a principled systematic approach to iterate that causal model that is the initial input to your analysis to check if the causal relationships that you postulate from the start actually exist or can be more precisely defined in later iterations?
Yeah, exactly. So our general preference and the general way that we're building the tool is oriented towards, let's model it first and then look at the data and then iterate. But you can start at any point. But fundamentally, you're exactly right. What you're doing here is based on subject matter expertise. You're drawing a model that is the way you think the world works, right? Just based on cause effect structures between these different variables and events. And then, there's a phase of looking at that. Okay, what are the front door paths? What are the backdoor paths? And backdoor paths are basically where you're kind of going back up a causal relationship, and the data would show that as a correlation, basically, right? But it's, so we can get there effectively, and we've got to close that off. So we've got to understand which variables to condition on in order to close that off, and we've got to make sure that we don't open up anything else. So that's kind of a process that we're going through, and the tools support that, and show you which are the backdoor paths and how to close them, etc. So there's that kind of process that you're going through. And then, you really do start digging into the data. Okay, given that structure now, and given what I need to close off, do I have all the data I need to actually fulfill that causal model? And if not, what do I do about it? Do I go find some additional data sources, or do I reduce the scope of the project? How do I do that? Because, if I've got a critical causal path here that's not expressed in the data, I have to make a decision. But it's kind of, in some ways, forcing those decisions at a pretty early stage in the process. It's not waiting until after we spent months, years, whatever, swimming around in data, hoping that we've captured the right relationships, only to find out that the data is not there to actually express it. So we think this is a very powerful process to go through that really changes the way we think about data science. And that's fundamentally what Pearl's work is about. He wants us to move up the kind of next rung or two on the AI ladder. And it is being seen by the industry generally as the next big thing towards AGI. Ultimately, we're not really too interested directly in that. That's a ways off. But our focus is on proving that this works on artificial narrow intelligence right now, classic industrial problems, and then but really helping people move up a rung or two on the AI ladder. Does that make sense, Christian?
Yeah, absolutely. I'm just playing with the idea that the process that you've just described in itself could be automated, at least to some point. So I'm not quite sure I understood how much potential is there to do that. And I mean, of course, at some point you probably always will be needing the human in the loop to review the results of certain intermediate steps.
Yeah, and that's partly why I mentioned the the NLP type path of how do I harvest potential causal relationships and structures from academic papers, manuals, whatever it might be, right? Some corpus of text. Now, early days in really making that work, right? As I'm sure you'll appreciate, but that's where we think some of the technologies built into TypeDB could be really interesting, as partly why we chose TypeDB, because we could see the power of that and giving us the potential to explore those relationships and open them up. Some of it, is effectively we're starting to automate it, right, by calling the do-why library and giving you feedback on the paths and everything. We do think it's a little bit dangerous to, just take it from a corpus of text. I mean, there's the old thing of no smoke without fire. Well, that's not really true, is it? In reality, if I have my pan on the stove with some a little bit of oil in it, it'll smoke and probably never catch fire, right? Depending on what kind of oil it is, etc. So it's just not necessarily true. And understanding the difference of those kinds of things is obviously very difficult, and it requires a bit of human intelligence for now. But clearly what we're describing there is one of the fundamental challenges in the path towards true AI, right? How do we build in and create a system that can actually deploy that level of human-like intelligence, the fundamentals of cause and effect, which is what we all learn as babies, right? When we're in our playpens and we're knocking over piles of bricks. If I knock this one out, so many fall down. If I knock it harder, more might fall down. I'm just learning cause and effect all the time. And unfortunately, AI as it stands today just has no understanding of all of that. So, you know, that's what they're the kind of fundamental challenges in moving up the AI ladder. How do we do that? And at the moment, we're at a point where we need some human intelligence to be applied to express that and help the system out. But it is fundamentally the direction we're going in to automate more and more of that.
Great. So thank you, Stu, and thank you, Christian, as well. Is there anyone else? I know we're over time, but I know we still got quite a bit of an audience. Does anyone else have any question to ask Owen or Stu? And then Jerry, as well as the CTO of the company, is also in the chat, very active. Does anyone else have any other question?
And now, Thomas, does everyone who's attended have our emails and so on so that they can ask any questions afterwards? We're obviously very happy to.
We'll, with your permission, we're happy to send those out. We weren't planning to, but of course, we'll be happy to send those. And if you have them, you might as well just add them in the chat if anyone wants to contact you directly right now. I know some of you are also on our Discord channel, so I'll post some links here as well. And yes, we'll be putting this online as well. There are already 2 recordings from the Geminos team on the Vatical YouTube channel. So if you search Geminos Vatical, you should be able to find 2 previous webinars that were done, I think, at our last conference for both, I think, Stu and Jeff, I think, did the first one. So there's quite a bit of content, I think, also to explore from the Geminos team. So they're very active online, as I can attest to that.
Yeah. And also, you know, if anyone's interested in a trial of this, more than happy to set that up. We want feedback on it. As I mentioned, from the point of view of the product, because it's built into Node-RED, which has got, I don't know, 10,000 plus users. It's very reliable, easy to use. And, you know, if people are interested in exploring it and want a quick trial in the run up to us formally launching the product, we're more than happy to set a few of those up. We can't do too many, but just from a sport perspective, but, you know, would love the feedback. So please let us know. Great.
So if there's no more questions, and again, if you do have any, feel free to put them in there. On our side, on the Vatical TypeDB side, we have a bunch of webinars next week. In particular, one that may be of interest to you. We're launching a new series or a new project, an open source project in the cybersecurity space. So there's a repo available as well that we launched, and we're doing a webinar on that. And I just shared the link of the webinar in the chat section. So if you're interested to check this out, we'll add that in there. Paul asked, will you put the link into the book mentioned on Discord? I guess that's one for the both of you. And I guess, you know, feel free to message each other also directly. I know, you know, and if anyone wants an introduction, feel free to message myself as well. We'll follow up with an email also with some of these links. But if we miss anything, you know, message myself if you want an introduction to Stu or Owen or Jerry, and I'll be very happy to facilitate that, as I've done already a couple of times to Stu and the team. So with that, is there anything else you want to add, Stu?
No, just thank you very much for setting this up, Thomas and the Vatical team. Really appreciate the opportunity to talk to your community, and we've had some great leads already from you, so very excited about that. And I think this, you know, the idea of adding causal modeling over and above the work that you've done on knowledge modeling, etc., is just a really powerful concept. So really appreciate everybody attending today and all the great questions, and look forward to having a dialogue with many of you as we go forward. Thanks very much.
Awesome. And thank you, Stu. Thank you, Owen. Thank you, Jerry, for being so active on the keyboard. And we'll see you next time.
Yeah, thank you very much, Thomas. Yeah. And thank you, everyone, for watching as well.
Thanks, everyone. Bye-bye.
Thank you, and bye.